Is this good?
That's good.
Okay, perfect. So, thank you everyone for coming, and thanks Occulture for having me. Maybe a little introduction to the talk. So, we all probably read a lot of articles on AI here and there. And I'm getting a bit wary of, everyone boxing this AI as the black box, and sort of, I find it a really, I get the framework. It's coming from like this attempt to bring the re-enchantment of the world and of the technology, right? As bringing something we don't understand and, new magic. But I think that's actually a very lazy take on this. So I think that calling something magic just because it's too complicated to get into it and actually properly understand how it works is not the right approach. So what I'm going to try today is just draw some very broad parallels between things which might be familiar for you because you're mostly occult practitioners here, and some AI sort of more in-depth look into the language models. And yeah, maybe let's start. And I'm going to let you, after this talk, to find the resonances with your own practice. I'm not going to try and impose some magical ideas on the AI. All right, so, Occulture quote bingo. Probably everyone seen some alternative to this quote already. But the interesting part is that in the beginning was the Prajapati, with whom was the word, and the word was verily Brahman. This is not from the Bible. As everyone who worked with the original text of Vedas or Upanishads knows how the translation can be very tricky, and this translation was most likely tweaked in a way to eerily resemble the very well-known quote from the Bible, right? So we can see this theme, this topic of word being some active power or active force creating the universe in many places. So I'm going to quickly just run through some references from the occult world, and then we're going to get into the more mathematical space of this. So everything started with the Tandava Natyam, which is the dance of creation and destruction of the auspicious Lord Shiva, where he, in the beginning of time, was beating his Damaru drum, and with every beat on the drum, next syllable from the 14 Maheshwara Sutras unwrap themselves. And these sutras consist of each letter of the Sanskrit alphabet and are believed to be the building blocks of the universe, containing the basic energies which constitute the physical space. There is a very similar notion surrounding the idea of Kundalini being consisting of the letters of the sacred alphabet, and we can see this echoing also in Kali's Varnamala, which are the skulls which she wears around her neck, which represent 51 letters of the Sanskrit alphabet as well. So there is this belief of certain cosmic code, these primal energies which constitute the space being present. In a very similar way, we can see this happening in the Jewish Kabbalah. And just this quote from Sefer Yezirat, which is one of the most important texts. He had formed, weighted, transmuted, composed, and created with these 22 letters every living being and every soul yet uncreated. So I probably don't need to go into depth with these topics. I'm pretty sure you're familiar with the aspects of Kabbalah and the letters being mapped to the paths between the Sephira, being mapped to the tarot cards, and so on and so on. And this very well-known quote from the Bible, also, let there be light, and then there was a light, is sort of a hint on certain naming, magic, the letters constituting the thing itself, light, right? The arrangement of letters. And we can, of course, see this a lot in Crowley's writing, where, the representation and mapping of the letters to numbers, and then finding correspondences between these is also a very important part. I really like this quote from Ahmad al-Buni, which was a Sufi mathematician and philosopher, which I'm going to read out. Know that these secrets of God and the objects of his science, the subtle realities and the dense realities, the things of above and the things from below, belong to two categories. There are numbers and there are letters. The secret of the letters are in the numbers, and the epiphanies of the numbers are in the letters. The numbers are the realities of the above, belonging to the spiritual entities. The letters belong to the circle of material realities and to becoming. So we can see this mapping and the intimate relationship of letters and numbers being hinted already here in the Sufi mysticism. And now, so keeping all this in mind, this sort of idea of primal energies constituting the reality, let's look at the sort of possible mathematical framework for this. So let's take a look at a space we know very well, very practically and intimately, which is the color space, right? So we have in the color space, in the regular encoding of colors, for example, computer purposes, we've got the RGB scale, right? Red, green, and blue. And we can think of these three as the primal energies of the color space, which all together can constitute any color we can think of, right? And the interesting thing is that this creates a three-dimensional space, right? So every point, every color belongs to a space. So we can start thinking in a spatial metaphors when thinking about color. Also, this space is semantic, right? The colors which are close to each other are similar to each other. And adding a certain value on one of the axes will bring more of that color in. So it's very... it has several properties we sort of want to keep in mind and want to think about. And this is sort of very natural way of organizing information for humans, right? We love to categorize things on the axis and then being able to draw points on the axis and sort of point ourselves as into one of the best kids and so on. It's like, this is necessarily reductionist because there is always one axis we're missing, which can completely redraw our data set. But for many practical purposes, it's basically the way how our scientific thinking works, or our thinking in general, to being able to organize and generalize information in this way. So now let's do a little exercise. So imagine we have a certain domain, and our domain being the dogs. And now imagine we have this huge group of wonderful slaughtering dogs in front of us, and we want to order them in a certain way. So what would be your first thought? How would you go about ordering in some way all these dogs?
Hair length.
Perfect. Size, hair length, both of them are perfect. So we've got two axes, right? First then would order them by size, the other one by hair length. Then we can think of many, many more, like the distance of the eyes, the pointedness of the ears, and so on and so on. And this way, we create so-called features, right? These are going to be the axis of our space, and we're going to be able to organize all these dogs in a way that we're going to create clusters. The dogs which are similar to each other are going to be close to each other in this space, and which are not similar are going to be further away, and we can go along the axis and see how, you know, the length of the hair changes, and so on and so on. So we end up having, you know, something like organized map of information. And now, this was a very close domain, which is quite easy to think about because we talk about concrete objects. But what happens if we want to talk about meaning in general? So you've got a basket of all the words ever mentioned, ever uttered. How are you going to create the features there, right? How are you going to organize all the words? Now, there's been a lot of literature and philosophy and linguistic books written about this, and in my opinion, it's a little bit too abstract for our brain to actually go about this and think about this and be able to conceptualize this problem the same way as we do with dogs. But this is exactly where we're able to bring in, the reason why this is difficult, let me first explain, from a machine perspective, is that, let's take an example of a word, right? We have a rock. And now, if we look at this word purely from letter constitution, right, in mathematical or in machine computer terms, then the word stone and the word pebble are completely unlike, right? Because they barely share a single letter. And without having a dictionary which actually map these two values together, there is no way for a machine to know that these are actually synonyms. But a word like lock is just one distance away, right? So this would be, according to a machine, much closer to it. So that's why we need to solve this problem with machine learning. And we use this thing called word embeddings for it. And it's based on one very surprisingly simple principle, which is that word embeddings are a learned representation for text where words with the same meaning have a similar representation. So we're creating a dictionary, which is some set of numbers or vectors, I'm going to get to it later, which maps words in a way that similar words by meaning are close to each other, right? So how is this done is that we start with a multi-dimensional space with random representation. We give every word, we just toss it into the space randomly. And now we run the machine learning algorithm, which goes through a huge amount of text, mostly scraped out of your own writings on the internet. And this algorithm will take every word which occurs in a sentence with another word, would take them and bring them in this space closer together, right? It's a spatial metaphor, so it works. They're gonna pull each other closer and closer. And now this is a very interesting algorithm because, for example, it allows us to solve a problem of having a word like jaguar, right? Which you're gonna find in multiple contexts. You're gonna find it in a sort of nature, documentary, jungle, animal kingdom, and so on in a context of this, but you're also going to find it in car advertising, right? So what's going to happen with this word jaguar is that every time we find a sentence with one or the other meaning, we're going to drag it in two opposing directions until the word finds its midpoint between the two sets of clusters of meanings. So we're going to be able to sort of access both of them. So this is the word embeddings. And now, what happens with these word embeddings is that we create this spatial metaphor for the words, right? We create, it's not going to be a three-dimensional world as it was in the RGB space, the color space. It's going to have around, for GPT, it's currently, I think, 12,000 dimensions, right? And we're going to create vectors out of this word, which means that as we had with RGB, each of these values had assigned certain value to it to represent the color. We're going to have 12,000 of these values. So it's going to be much bigger, much more complex, but still, like, we can think about this as points in space, just not that easy to imagine. And this spatial metaphor is very powerful, and it allows us to do also one very important thing, which are mathematical operation. So right now, thanks to this arrangement of the words, we're able to add up meanings, right? Which means we can take 2 points, like for example, king and royal, like for example, man and royal, 2 words. We can add them up together, and we're gonna arrive in this space to a place where the king exists, right? So we're able to add meanings in a mathematical manner to actually arrive to the actual meanings, right? So we created a semantic space for the words. And in a very similar way, we can, for example, do that with times, like verb tenses. And now keep in mind that this space never saw any syntactic rules, never saw any sort of rules how to build a language. This all is a product just of one very simple rule, and that's that the similar words appear in similar context. Yet, this way, we were able to create even a mapping which will give you a country and capital based on their position in the space. So you can take any country which you find in the space, add a meaning of capital town, and you're going to arrive on the actual mapping of the capital town of that place. So one thing which it does as well is, now this is a projection of this huge space into 2 dimensions, so we can see it in a more easy way. And you can see that it creates clusters of meanings, right? So we've got the, I think it's kitchen utensils in light blue are clustered together, words with similar meanings. I can't see there what's there on the right, but they're gonna sort of, according to their meanings, create clusters. There are a lot of tools now which you can use to explore these world analogies, and I was sort of playing with one of them. This is actually not very good. These are word embeddings before this whole GPT thing appeared. They are quite old and they are not very good, but still, here you could come and draw what you want to see on your axis. I put there good and evil, honest and dishonest, and I ask it to plot a couple of words for me, right? So in the good and innocent part of the map, we've got things like saint, angel, virgin. And in the evil and dishonest, we've got Hades, Lucifer, trickster, coyote, and so on. So you can see that just purely based on the context of like seeing our myths, seeing our stories, it was able to pick up on these qualities of these words, right? Without anyone ever drawing these attributions into the data set. It's an emergent property of this data set. So what happened here is that we basically, with the word embeddings, create, or it's a mathematical space, right? We've got the axis there, and for theoretical purposes is a continuous space of meanings. Like mathematically, there exists an infinite amount of points in this space. For practical reasons, when we use it in the machine context, it's not really like that because we've got some computational limitations, but in theory, it is like that. And what we did is that with our human language, we poked a holes in this meaning, right? We drew all these little dots, which are our labels for the meaning. These are the words we have. And if we think about it this way, there are some very interesting features of this space. And that's that between any 2 points we take, any 2 labels we have, any 2 words we can pinpoint on this map, there is an infinite space in between, right? So we can interpolate the meaning and create and pinpoint any point in this distance and create a new meaning or give it a new label which has already predefined meaning, right? So all we have to do is take the mathematical position of, 20% snake and 80% boy and give it a name. And this word will already have a meaning in this space, which then we can reference to. And in a very similar way, the space is fractal. So the more you know about a certain area, the more dots appear in that space, right? So in the beginning of, time, we had one word for a monkey. And with a further research and further sort of exploration of the nature and so on, we started naming the species. And then, this any area is sort of growing as we create more data sets within this subspace of the meaning. So these are 2 very, very interesting features. And I wanted to mention this because I find it very interesting. So what happens if you create these embeddings on the English language, and now you take a huge corpus of Japanese texts, There is no direct imagine there is no direct translation between these languages. But we take a large corpus of Japanese texts, we train the embeddings using exactly the same algorithm, and what happens is that we've got two sort of spaces of meanings, two embeddings, which then we can map on each other and create a translation of languages we never had translation between before. And that's because the meanings are organized in a very similar way. Of course, the mapping of the words themselves wouldn't be identical because, you know, there are some intricacies to Japanese language which are not present in English and so on. But because the underlying framework, or the underlying hardware, which is running the language, is still a human mind, these universes are going to be more or less mappable against each other. And also, thanks to this mapping, we're going to be able to see where are the differences, where are the similarities, and sort of deduce some cultural implications of this, or maybe create better translations, better translators, and so on. Now, this brings very interesting possibilities for translation of unknown languages, right? What if the corpus of data was large enough for example, linear B, which hasn't been cracked yet, to create an embedding based off this language and just map it on the top of the meanings we already have. So, unfortunately, the data sets we have are way too small to do this yet, but in case we found a huge basement full of tablets, this might be eventually possible. And of course, maybe one day we're gonna be able to crack Voynich manuscript as well. It's been tried with the word embeddings, it didn't work. So unfortunately, that's probably not happening. But yeah, and there is one more implication which I would like to sort of leave here. And that's that each of us have their own mapping, their own set of word embeddings in our head, right? And in the future, when each of us trains their own set of embeddings, we're going to be able to basically see the differences in the space of meanings we have between us mathematically. So we're going to be able to see that when one person talks about love, the love is in a very different mathematical position to the average and to the other person they're talking to. So then we can sort of maybe create a better translations how to talk between each other, right? So this is one aspect. And then I would just like to sort of toss a couple of ideas here. Perfect. Which I'm just gonna leave them hanging in the air. So one of the practical purposes of this could be creation of some sort of spatial hypersigils. So you could take a set of words which represents your desire and create a multidimensional path in this huge space, and then work with this shape, either project it on a lower dimensionality, draw it on a paper, or anyway, then you work with sigils. So this is one possibility, sort of going in this direction. And then there is a very interesting one I'm sort of trying to get into, which is synthesis of new symbols. Now, imagine you dreamt of something which, as dreams do, is really hard to put into words, right? It was an apple, your old friend, and something else at the same time, right? So what you can do is that you can sum up these three meanings, create a new point in this space, which you're gonna name dream entity 1, 2, 3, and then you can take this meaning into GPT and ask it what it actually means. Because this GPT or any language model will be able to understand its meaning, right? Because that's how it operates. The fact that we didn't have a label for it is not important for it, because mathematically that point exists. So this could be one very interesting way how to sort of synthesize new things, new entities. You want to, summon some specific desire or anything, and then you can probe the language model itself. There is also a very interesting thing I was thinking about and don't know yet how to go about it, and that's the shamanic twisted language. which, for example, Maria Sabina was using in her writes, which is sort of using a language in a way which describes things not the way they are, right? So it uses some sort of weird, ununderstandable metaphor, and maybe it would make sense to look into this poetry, into these chants, and see whether there is maybe a mathematical mapping, a transformation we could use on these sentences to actually arrive at their true meanings. Or, you know, I'm just throwing this in the air, sort of shower thoughts. And then there is also a question how the model goes around things like Finnegan's Wake, which, again, have meaning, don't have meaning, you know, it's complicated. I'm still waiting someone to use the language model to crack this. And yeah, I think that might be all. So, thank you. And if you want to sort of refresh all the information I throw at you right now, you can go to mercuriumminutes.substack.com, and there is this whole written down as an article with sort of more links to get into and so on. So, yeah, thank you.
Thank you, Karin. Good, so